Welcome back to my course on how do you build AI agents from scratch. I'm going to recap everything we've built so far because honestly, it's pretty impressive. So we started with the basic chat. Started with using the OpenAI playground, the large language model, to have a back and forth conversation. We noticed that the language model doesn't have access to any real-time news. It doesn't have access to any tools. It can't really do anything other than chat. We describe ways to improve this. For example, having the language model respond in JSON, or having the language model generate code that we execute otherwise. Then we formalize this more in a concept called tools. The language model has access to tools which we can then execute and then get a response. Finally, we add an orchestration loop. This builds out an AI agent. AI agents shouldn't be able to execute everything indiscriminately. You need some way to control whether the agent can execute a command or if it needs approval or additional clarification from the user. You can use a whitelist, a blacklist, or even just a toggle between automated and semi-automated mode. Tools like Cursor and Claude Code allow you to do this. We've also introduced the concept of memory. We can store memory simply with just plain dumps and markdown files. We can store memory smarter, like having different files for different things and having a language model summarize the memory and place it in the correct files. We can do advanced memory. We can take 100 pages of documents, put each document in a vector database, and then at runtime, we can query the database for relevant documents, put it into the system prompt, and then answer the questions. Or we might have a different memory architecture where we create these memory structs that have these tags that are queryable at runtime and can be injected into the AI's context at runtime. Now we're getting to the final stretch. That is, after our agent runs, how do we know if it did a good job at all? This brings us to an extremely important concept called evaluation. Evaluation is you deciding how you're going to grade how your agent performed. And this can be in a number of key ways. So right now, this is an evaluation system prompt for a specific tool. This prompt, given the user's requests, the SQL query, and the SQL query results, it gives a grade. The grade, it can be 1 for a perfect query, 0.9 for something close, 0.6 but it's flawed, or 0.2 or 0 if it's just outright wrong. And similar to other system prompts, we have examples that has an input and the output, and it gives it a grade. And so we can basically give instructions on how we want it to be graded to an AI model. We can get the score, and now we know exactly how good the model did its task. Now, this is just one way of grading a language model. This is grading on pure accuracy, but sometimes you want to grade things that are a little bit more subjective, like did it accomplish its goals? Or maybe there are several things you have to account for. In this example, we're just outputting one score. We could output multiple different scores and see how well the language model did in different tasks. Here's an example of a system prompt that outputs multiple scores, and it does a weighted sum. This system prompt takes as an input an entire agent run, everything that happened, and including traces, which I'll talk about a little bit later. But it takes an entire agent run and it gives it a score in multiple different categories, and then it weights it. So it's going to respond with this JSON with a summary, a description, all these scores, and this JSON can be parsed and then be used to iterate over time. Or at least that's the idea. But in order to properly evaluate an agent, especially the full agent run, we need the entire context of what the agent actually did. Moreover than that, we might just want to monitor it. What if we spent $70 in an agent run, but we have no idea why or how? We need to know that sort of information. That brings us to a key important part, which is observability. You want to store all your inputs, your outputs, the number of tokens, the cost, anything you need to know. You want to store all of that information as the agent runs in a database so you can see exactly what happened step by step. And the fun thing is, you don't even have to read it. You can give all that information, dump it to an LLM, and then you can ask it to summarize what happened. But by doing this, you can essentially teach your agent to achieve specific goals, and it's more or less objective. But you don't just need an LLM to grade an agent, right? You can have grading criteria on if the time it takes. You know, what if you have an AI agent that's trying to triage production outages? If it's a Civ 1 and it took 20 minutes, well, we lost $10 million. That is not a good agent. Or you might consider something like cost. You know, if you have an AI agent that's sending emails and it's costing you $60 per email, that's not a good AI agent either. There are different criteria, some objective that don't require LLMs, some subjective that do require LLMs, and you just have to choose what evaluation pipeline makes sense for your specific use case. Now, one important thing that I want to bring up with this is when you're evaluating the agent, you have to be very careful that your prompt is actually grading the thing that you want to improve. Let's take a concrete example of creating trading strategies. Let's say you use the backtest performance of your trading strategy as the thing you're trying to optimize. If your goal of the agent is to produce great backtest results on a certain period in the past, then that will probably work really well. Your agent will improve quickly and you're going to create some amazing agents that work all the time. But if your goal is to build an AI agent to execute real world trades, then the backtest performance, while it's somewhat important, is not actually the key thing you want to optimize. You might accidentally build an AI agent that produces very good backtest returns, but produces horrible real world live trading returns. You have to make sure the thing you're optimizing is the thing you want improved. If your score is wrong, then you're going to be improving towards the wrong outcome. And this is one of the hardest things to get right with your AI agents. Believe it or not, we're finally done. We've talked through everything it takes to build a real world production agent. In my next video, I'm just simply going to recap everything we've learned so far because it's a lot. But if you understand it all, excel. You will ace your AI native software engineering interview or be a superstar on your tech team.